Welcome to this screencast where I'm going to try to talk a little bit more about the colorimeter and how it works to help make this a little bit, hopefully try to make this a little bit simpler for you, or easier to understand anyway. So we're going to use a colorimeter, and if we were to take that box that's the colorimeter in our lab and section it, we would see that this kind of in section is what the box is going to look like. So there'll be a light source inside here, and there's a knob on the top that can switch which wavelength of light is being fired at our sample. Then there is a detector over here. It's inside the box, and that is then going to be linked up to the computer via the Lab Pro or the Logger Pro, and the computer can read the absorbance and then also the percent transmittance over there. And so then this is where the sample would go. This is where your cuvette's going to go, right? And there'll be a little slit here, right, where the light is going to come through. Now, in our lab, we're not using blue light. We're going to use red light of a wavelength of 635 nanometers. Right? So we're not going to. It's not going to be blue. It's going to be red at 635 nanometers. I think in another screencast I made a mistake and said 535, but that's down in the green range. So this is 635 nanometers, and so the light that's going to be coming through there is going to be a red light. And that red light is going to pass through the sample and then be detected by the detector on the other side. So the question then is how much, well, how much of that red wavelength of light, how much of that 635 is going through, right, the sample? Right? Well, it depends on the sample. So if our sample is a sample of chloroplasts, right, they are going to be green in color. Right? So what do you know about green? Well, green is going to absorb red. Green absorbs red, so the absorbance would be high there. But that's going to cause a little bit of an issue for us. So what we need to do is calibrate. And there's a procedure in the pre-lab there how to calibrate this. And in the procedure, it says to use distilled water, but we are going to use cuvette 1. We use cuvette 1. And cuvette 1 is green. It has unboiled chloroplasts in there, but no DPIP. Right? So what's going to happen in cuvette 1 is green, 635 is going to go through there, and most of that is going to be absorbed, and very little of that is going to be able to go through. Right? So it's going to be relatively high absorbance. What we're going to do is during the calibration, you're going to tell the machine that however much light is coming through here, most of that 635 is going to be absorbed, and very little of it is going to be transmitted. But you're going to tell the machine that whatever value this is right here, to make this 100% absorbance and 0 transmittance. So this is the calibration step right here. We're using cuvette 1 to calibrate. So what we're saying then is that when I have cuvette 1 and I have 635 going through, whatever's coming through, we're using this as the standard, right, starting point. Right. Okay. So we're setting the machine, setting the colorimeter to use that as the zero point. Right? We're zeroing that out. Now, in the other cuvettes, then, cuvette 2, 3, 4, and 5, you're going to put chloroplasts in each one. So those are going to be green, except for the last one, you're not going to put any in. And then you're also going to put DPIP in, so there's going to be blue dye in there as well. Right? So we've told the machine to ignore the green, right, or set this as 100% admittance or 100 admittance and admittance, absorbance, pardon me, I'm tired, and 0% transmittance. But in cuvette 2, 3, 4, and 5, you also have DPIP. Now, DPIP, when it is reduced to DPIPH, goes from a blue color to a colorless color. Now, blue, right, if I have a blue sample here and I fire 635 at it, right, well, blue is going to absorb this red wavelength of light, right? So it's going to be relatively high absorbance and relatively low transmittance. But over time, right, and that time is when you have the cuvettes behind the light, behind the heat sink, or behind the heat sink that's between the samples and the light. So over time, what's happening is photosynthesis. And how do we know how much photosynthesis is happening? We're going to be monitoring how fast this blue goes to this colorless. So at specific time intervals, we're going to take our cuvettes, put them into the colorimeter where 635 is being shot at that sample, and we're going to be able to know, okay, the absorbance at time 0, at time 3 minutes, at time 6 minutes, at time 9 minutes, etc. Right? What should that absorbance be doing? This is a rhetorical question now. So what should the absorbance of 635 by the DPIP be doing? What should the transmittance of 635 by DPIP be doing? Right? And I think I'd referred to this in class, right? So you want to know the absorbance of the light, the absorbance of that 635 by the pigment, DPIP. Right? And so in this way, we're going to be able to determine the rate of photosynthesis by how fast that DPIP is being reduced. And this, of course, is linked to the light-dependent reactions. So how fast the light-dependent reactions are happening is how fast photosynthesis is happening. So we're using this dye reduction technique here. And that's a little bit more about the colorimeter, how it's working, how the setup is functioning, and what you're going to actually be measuring and calculating in class. Okay. I hope that was a little bit more helpful. If not, come to class ready to talk about it and discuss it. Okay, thanks.